So let's get started. Some of the kids might not join even today, and the reason being the festival season. They still are the festival that is not over yet, and that is why some of the kids might get late or might not join. Hello, Adya. So let's do a quick roll call and we'll get started. So we have Adya, we have Advik, we have Milana, Moira, Nihan, Urvi, Saurya and Suhina. That is here? Okay. So before we start, Tasvik, move a little bit to this side so that I can see you better. Okay. Arihan, sorry.
Can I call my father?
Yeah. So Arav is also here. Arihan is here as well. So my question to you guys. So far we were talking about probability. Anybody in the class who is not sure about the basics of probability before I can jump onto deeper concepts. So we talked about what is probability, what do we mean by a fair opportunity, how do you define probability as a concept. Tasvik here, make sure that you are paying full attention to the class. I see you busy with something else. Put the notebook down, no? That is not going to be acceptable, okay? Alright? So my question to you guys is that anybody in the class who doesn't recall what is probability, how do you describe it mathematically? What do you mean by compound events? Anybody in the class who is not clear? It's okay. You can call out that, okay, I'm not clear, and I will explain that. But assuming that everybody is clear, saying that I'm clear but you're not clear, that will make it a little complicated. So it's okay to ask if there's any doubt that you guys have in your mind. Tasvik, I will not remind you again. Put the notebook on the table. Notebook on the table, please. Yeah. And pay attention to what we are doing. Yes, Arihan, go ahead.
Sure, that was quick.
Okay. My question to you all is, anybody in the class who is not clear about what is probability or how do we describe probability or the basic formula, how do we, I see Adya with the t-shirt for the class. Thank you so much. I was wondering if kids who have got the t-shirts will ever wear it. So, good. I had forgotten about it. Hello, Sanvita. Alright, so the question to you all is, anybody who is not clear about it, or I can assume that everybody is clear, let's get it rolling first. Maida, are you clear? What is probability, whatever we have learned so far?
Yes, sir.
Okay. Let's look at some problem that I had put across for you guys, and then we will see who is clear and who is not. We have, I'm going to waste some time drawing something. So we have, in this question we have two diagrams. Don't make that sound. Diagrams 1 and this is diagram 2. Let's look at the diagrams. This is B, from this C, this is C, and then everything has a T. Okay, this is one diagram. A second diagram is B, C, T, and then And you guys must be thinking what exactly it is. Let's go through the question first. Desmond lives in Melbourne and is taking a trip to Sydney. Somebody is living in Melbourne. Look, Gayatri. So let's quickly check who all joined in between. So we have Arihan, Vasundhara, Suhinas, Gayatri, Shaurya, Urvi, Sanvita, Nihan, Myra, Hiranya, Milana, Advik, Arav, Aryahi, and Adya. Okay? And in the classroom we have Adya and Tasvik. So we are continuing from where we had left with respect to probability, and I asked the question like who all are clear about what we have learned so far or who is not, and there was no answer to it. So let's see how comfortable are we with the probability concepts when we solve some problems. So I have just drawn these two diagrams, and I know it might not be very visible. So this is diagram 1. Here you see B and B. In the second level you see all C's, and the third level you see all T's. From 1B there are 2 branches of C. Every B there are 2 branches of C, and every C has 2 branching out of T in the diagram 1. And here what you see is B, C and T are 3 branches coming out from the root, and then from every sub branch you see 3 branches further coming out, which is B, C and T. And now I'm reading the question and we'll see what it means to us. Somebody lives in Melbourne and taking a trip to Sydney. He can travel to Sydney and back in 3 different ways. So from Melbourne, he can go to Sydney and come back from Sydney to Melbourne in 3 different ways. By bus, cab or train. So B stands for bus, C stands for cab, and T stands for train. Okay? Which of these 3 diagrams can be used? Okay. He chooses how to get to Sydney and back at random. Which of the 3 diagrams can be used to find all the different ways that he can take to get to Sydney and back? Diagram A or diagram B? So, these 2 diagrams are showing different ways somebody can start from Melbourne and go to Sydney and come back. And B, C and T stand for bus, cab and train. Okay? Now, by each of the diagram, he's trying to represent somebody starts from one place and returns back to the same place. So the question here is, which of these 3 structure diagram is representing his journey from Melbourne to Sydney and return back? Not sure if you guys heard the question okay, or if there is something that is not clear to you as a question first. Forget about the solution part. Did everybody hear it? These 2 diagrams are showing the path in which somebody can go from one place to another and then return back. Now the question is, you have these 2 diagrams, you're starting from some place and then going to other place and then you are returning back. Which of the diagram is showing that correctly? Yes, Adya.
It's diagram B. Because it said he had to use it randomly. So like the first part, he could use bus, cab, or train. And then like once he goes back, he could like choose like on the bottom part.
Okay. That's a good observation. Let's hear everybody else's thought process also. Again, even if I'm saying this is part of probability, it doesn't have any deep concept with respect to probability. Tasvik, struggle with this problem, not with your drawing. Here, no, so I want you guys to spend 1 hour with me, okay? With utmost honesty. So here. Now, I gave you guys a question, I'm saying it's a probability question. Maybe it's a probability question, maybe it's not. But question says, these 2 diagrams are showing how somebody goes from Melbourne to Sydney and then returns back. And he chooses it randomly. Now, by looking at these two graphs or these two diagrams, which one is representing that journey where he is picking up things randomly and going in any predefined order? Yeah.
Diagram B because from Melbourne to Sydney you can choose any, so you can choose either bus, cab, or train, so he chooses them. Then when he comes back, he can also choose B, C, or T.
Yeah. Okay. Adya. This is more like a story. It's not a problem. Anybody else? Suhina, Myra, Aryahi, Urvi, anybody? Milana? Okay, so from this question, okay, I know you guys are needing some jump start kit. So here's the jump start kit for you guys. This question says that somebody is traveling from one place to another place and he can randomly choose anything. If you look at this diagram, what does it say? He starts, takes a bus. From bus, he takes cab. And then after the cab, he takes the train. Bus, cab, train. Bus, cab, train. Bus, cab, train. And return same path. This is restricting that flow. It's saying that you have to first take the bus, then cab, and then train. He cannot take bus and then train. So here, if you look at this one, it says that okay, you're open to all options. There is no restriction. If you're taking first leg as bus, your second leg could be bus, cab, or train. If you're taking cab, then also you have all three options open. If you are taking train, then also you have all three options open. So this is representing what are the different options you have. Probability is all about that. When you are talking about probability, it says, okay, what are the different options you have against the total number of options. That is the probability of certain event. So this T structure or the graph or diagram, whatever you call it, it gives you that ability to explore all the possible options, and then if you have to find out the probability of picking bus and bus, let's say if you look at this, you have 1 option, 2 option, 3 option, 4 option, 5 option, 6 option, 7 option, 8 option, 9 option. If somebody says, what is the possibility of getting bus in both the legs? Total options are 9, bus and bus is only 1. So 1 out of 9, that gives you a probability, 1 out of 9. If it says, what is the possibility of getting a bus and a cab? So you can say, get a bus and a cab here, you can get a bus and a cab here. 2 out of 9. Yeah? So basically once, in terms of probability, you will see that it's all about we figuring out what is the total number of options and what is the option that we are wanting to consider or compare with. That ratio is your probability. Yeah? So this was the first question. I know it was a jump start question, so it might have taken a little bit of time for you guys to get your head around it. Let me pick up the next one. Okay. James lives in San Francisco and works in Mountain View. James lives in San Francisco and works in Mountain View. So Mountain View, if you guys don't know or remember, Mountain View is a place very close to San Francisco, very close, I think close to 60 miles away from there. That is where you have the Google office. Okay, one of the Google offices. So he lives in San Francisco and works in Mountain View. So maybe James works in Google maybe. In the morning, he has 3 transportation options: bus, cab, or train. In the morning, he has 3 options: bus, cab, or train to work. And in the evening, he has the same 3 choices for his trip home. Okay. If James randomly chooses his ride in the morning and in the evening, what is the probability that he will take the same mode of transportation twice? I trust me, this is not a very loaded question, but it's a word problem. So it gives you that reason to be confused. But if you break it down, you will not be confused. So I'm reading the question one last time. I will let you guys struggle with this one, okay? Because without struggle, there is no fun. James lives in San Francisco and works in Mountain View. So this is more like a compound event where we are talking about going and coming back. So there are two events that we are talking about. They might be dependent or independent depending on how you interpret it. So let me read the question for you guys and let's see how you are dealing with it. Everybody listen to what I'm saying so that you can deal with it. And guys, everybody has turned off their videos. Keep your videos on so that you guys are with teacher and I'm with my students, not like an AI agent. James lives in San Francisco and works in Mountain View. He has 3 transportation options: bus, cab or train to work. And in the evening he has the same 3 choices for trip home. If James randomly chooses his ride in the morning and in the evening, what is the probability that he will take the same mode of transportation twice? Everybody heard the question? Goes from San Francisco to Mountain View. He has 3 options in the morning, 3 options in the evening. If he randomly chooses whichever mode he wants to use, what is the probability that he will take the same mode of transportation twice? Yep, Advik.
1/9.
1/9. Did you rush for it? I would say yes. Arihan.
I got 1/3.
1/3. Verify. Okay, I'm not saying Advik is right, Advik is wrong, or Arihan is right or wrong. Whoever has completed the answer, verify it. Adya.
1/9.
1/9. Same recommendation for you also, beta. Revise what you did and see if you are missing something or not. Okay?
Sorry, late, sir.
No worries, beta. So right now we're dealing with the probability problems. So I told everybody that I'm not going to teach anything new today. Focus is on practicing probability problems. Okay? So this question I'll repeat for you, Sami. This question is: James lives in San Francisco and works in Mountain View. In the morning he has 3 options, three transportation options: bus, cab or train to work. And in the evening he has the same 3 choices for his trip home. If James randomly chooses his ride in the morning and in the evening, what is the probability that he will take the same mode of transportation twice? Yes, Sanvita.
I got 1/3.
Okay. Sammy?
I also got 1/3.
1/3, so quick. Okay, let's see Nihan.
So the question is how much, is the chance for the same problem?
What is the probability of he taking the same mode of transportation twice? Sorry,
I think it's 1/3.
Arav. Arav? Sorry?
I got 1/3.
You got 1/3, okay. What is cooking up? Think about it. Break it down. Math. Arav, stop crying. Don't be a crybaby. Okay. Anybody? Aryahi, Myra, Milona. Give it a try. Tell me. Right or wrong doesn't matter to me much. Urvi. Suhina was. I'm sorry, beta?
I'm still working.
Working on it? Okay. Nihan,
1/3.
1/3. Tasvik, that fish will help, not help. Are you trying fish in a math class? What are you doing right now? I asked a question, right? You heard the question. Why don't you solve it and tell me the answer? It's a very short duration class, 1 hour. If I just let you guys solve 3-4 problems, the class gets over. So I expect you guys to use it effectively. Vasundhara, Gayatri, any thoughts? Saurya? Staying quiet is not an option, beta, okay? Everybody has to tell me. Yep. Give it a try. Go wrong. It's okay. There's no penalty for going wrong. Yes, Aryahi.
I got 1/3.
You also got 1/3. Okay. Suhina, Vasundhara, Urvi, Saurya, Moira. Yes, Milana.
I got 1/3.
You also got 1/3. Now let me randomly pick somebody. Okay, I'm not trying to pinpoint, but I'm just trying to see what is the thought process that you guys have. So yeah, Myra,
I got 1/3.
you also got 1/3. Now question to randomly. I'll pick randomly. Okay. So Milana, tell me, beta, how did you get to 1/3? What made you think so? Milana, can you describe it?
Oh, sorry, I didn't hear you.
Yeah. Yeah.
So, if there were like 3 options, and if he picked one of them, then that would be 1/3. And even if he did it twice, the options are still 3 and one of them. So it would be 1/3.
Okay. How about Sami?
I said 1/3 because if he takes the bus to go, like if he takes one mode of transportation to go there,
Mm-hmm.
he'll have to pick again. But even if he picks the same one, it'll still be 1/3 because there's always 3 options.
Okay. Arihan.
We're the same.
Okay. Arihan.
I also put 1/3 because I take it like step by step. So there are 2 modes of transportation that he has to take. So since he has to get the exact same one 2 times, and it didn't specify which ones, on the first one he has a 100% chance of getting one of them. And on the
Okay.
third and on the second try, he just has to have a 1 in 3 chance of getting that same one again.
Okay.
If he had bus on the first one, it would be a 1 in 3 chance of getting bus on the second one.
Okay. How about Sanvita?
I also got 1/3, but I got 1/3 because there's only like 3 favorable outcomes, which is bus both the times, cab both the times, or train both the times. But there's like 9 total outcomes, so then 3/9 is 1/3.
Exactly. That's a more convincing answer. Okay. Now again, this is morning. This is evening. Okay. He can pick bus, cab, or train. Let's say he picks bus in the morning, cab in the morning, or train in the morning. He can choose one between the 3 options. Okay. When he picks bus, he has in the evening he can pick bus, or he can pick cab, or he can pick train. Same thing. Even if he has gone by cab, he can again pick bus, cab, or train. Even if he has picked train in the morning, he has again 3 options: bus, cab, or train. There is no limitation. They are independent. So if you look at how many options he has, this is the bus and bus one combination: morning bus, evening bus, bus and cab, bus and train, cab, bus, cab, 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 train, train, bus, train, cab, train, train. 9 options. 1 option, 2 option, 3 option, 4 option, 5 option, 6 option, 7 option, 8 option, 9 option. Total 9 options. So probability, if you remember, probability is nothing but something over total number of events. Total number of events. Total number of events or options. by the option that you are interested in. So we have total number of options is what? Bus, cab, bus, train, cab, bus, cab, train, bus, train, cab, train. Total 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 9 combinations. Out of that many combinations, how many are the same combination? Meaning mode of transport used being same in the morning and evening both. Meaning either bus, cab, train. Only 3 scenarios when the mode of transportation used were same. So 3 over 9. Okay? And that became 1 over 3. So this diagram that you are seeing, or the tree structure, whatever you call it, this is another way of finding out probability by quickly breaking it down into all the events or the possible options that you can come across. Did it make sense to everybody? See, this kind of thing suits me because of my limitation with the intelligence. Somebody who is less intelligent needs something more pictorial in nature, right? Right? When you look at the babies, why do they like those cartoon movies and all? Because it's more pictures. It's easy for them to relate. Their brain is still growing. So after a certain age, your brain stops growing. That has come to my situation now. I understand things when they are simpler. See, Arav is crying again. If I say, Arav, you are less intelligent, he will cry. If I say, I am less intelligent, then also he cries. Don't cry, Arav, it's okay. Okay, so coming back to a serious discussion, here, what I'm saying is, regardless of what I claim for myself, right? Worst teacher, less intelligent teacher, whatever it be, my goal is simple. I'm trying to make things come to you in a very simple form. Whether it comes by me claiming as the worst teacher doesn't matter. But if I rush through it, okay, say there are 3 combinations: morning bus, evening bus, and then these 3 combinations, total combination 9, 3 over 9. That would not make much sense to you guys. When I break it down to simple, pictorial, repeatable thing, then you will believe me, right? So that's what I'm doing right now. Whatever I claimed, keep that aside. Don't worry. You will not have any problem understanding things from me because of my intelligence level. I'll explain things, everything that I teach. Okay, don't worry about it. Alright? If anybody is concerned about your teacher's intelligence level, don't worry about it. We'll take care of it. But is this clear? Yeah? Okay. Adya is clear. Milana, Saurya, Gayatri, everybody clear? Sanvita, did I copy paste your concept? I did?
Yeah.
Okay, cool. It's okay, we are on the same page. Let's go to the next question. It says, if you flip 3 fair coins, what is the probability that you will get a tail on the first flip, a head on the second flip, and another tail on the third flip? I'm repeating the question one more time. Yeah, dear, you saying something?
I got an 8.
You got an 8?
Yeah. An 8.
A. I'm just reading a question. I don't know whether I have A or B as an option. Let me read the question first. Yeah, no, there is no A, B option actually. You have to calculate. So let me read the question one more time. If you flip 3 fair coins, what is the probability that you will get a tail on the first flip, a head on the second flip, and another tail on the third flip? So there are 3, you flip 3 fair coins, so there are 3 fair coins which I am flipping. That's it, don't do anything interesting. Get to the question. 3 coins are flipped. What is the probability that you will get a tail on the first flip, head on the second flip, and another tail on the third flip? Yeah, now you have to find out the probability of finding a tail in the first flip, head on the second flip, and tail on the third flip. Yes, Arihan.
I got
1/8. Okay.
Yeah.
Everybody heard the question, right? Milana, Sanvita, Hiranya, Myra, Nihan, Sammy, Suhina. Suhina is very quiet today. What happened, beta? All good?
Yes, sir.
Okay. How about Vasundhara? Everybody heard the question, right? Vasundhara, okay? Not upset with your teacher, right? Okay. Urvi, okay? Okay. Everybody, okay? I'm calling out some names. No need, no reason for pointing out somebody, but yeah, I'm just trying to make sure that everybody is with me. Aryahi, all good? So you heard the question. You have 3 fair coins that is flipped. What is the probability of getting a tail on the first flip, head on the second flip, and tail on the third flip? I got one answer. I don't know whether this is correct or not. Let's see. I love what you're doing. Yeah, Aryahi. It's okay. Yeah, Vasundhara, tell me.
I got 1/8.
Okay. Advik,
1/8.
1/8. Gayatri. Tell me, beta, I could not hear you.
1/8.
1/8. Sanvita.
1/8.
Okay. What are you doing? Tell me. I see something fishy. What are you doing? No, so flip it down. You don't have to be and solve this problem, okay? So that if you go wrong, that's okay, but not trying to solve and doing something more interesting is not acceptable. I'll give you guys 2 more minutes before I jump onto it. Yeah.
Pass it on.
1/8. Wonderful. I really like what you're doing actually. This is the way you break it down. Okay? Okay. So I will show you guys what Adya is doing this, okay? She literally broke it down based on whatever I said. So flip 1, flip 2, flip 3, and she looked at all the possible options, and then she's telling you what is the probability. This is one way of breaking it down always. So good job. Okay? Alright. So everybody gave me 1/8 as an answer. So Gayatri, who talks less. So Gayatri, can you just explain it? How did you get 1/8?
First you said 3 coins. The first is tail, the second is head, and the third is tail. So I broke it down and see what all options we can get if we flip the coin 3 times. And then I got 8 different options. And then tail, head, tail was one of them, so I got the answer as 1/8.
Wonderful. Okay. So everybody got that. So there are 2 ways of doing it. So today, I think I'm pretty much done with the problem that I had for you guys, but I wanted to kind of put these concepts together and then derive some conclusive interpretation from this. So first, let's try solving this problem. So the question was that there are 3 fair coins. Coin or 3 flips of a fair coin. Any which way is okay. So let's say, I'll say flip 1. I'm just copy pasting from whatever Adya did. Flip 1, flip 2, and flip 3. Okay? So it says fair coin. Whenever you hear the term fair coin, it simply means that there's nothing that you can massage. There's nothing that you can change. There's nothing that you can manipulate. Okay? It's a fair coin. Head or tail, you have no control over it. So if I'm getting a head in the first flip, I can get head or tail. Okay? For head in the first flip, I can get a head or I can get a tail. Okay? And for this head also, I can get a head or I can get a tail in the third flip. So you got head in the first flip, you can get head or tail. And then you got a head, you can get a tail or head. Similarly, for this also you can get a tail or a head. And when you get a tail, you can get head or tail. For this head, you can get tail or you can get a head. For this also, you can get a head or you can get a tail. Yeah? So, you can put the head, tail as one option, head as second option, head, tail option, head, tail, head option, tail. So basically, net, 1, 2, 3, 4, 5, 6, 7, 8. 8 options are there, and out of which it says, what is the possibility of getting a tail, head, and tail? So this one is ruled out. I'm not looking at this part. Tail, head, and tail. This is the only path. This one, here to here and here to here. This is the only path that aligns with what has been asked. So 1 out of how many options? 8. This becomes a probability for us. And everybody, whether you guys did it by drawing it or by applying some formula, both ways the answer is correct. Now, there is a concept. So here we are talking about these are the compound events. First event, second event, and then the third event. A lot of things are happening together. Now when you talk about compound events, meaning you are not looking at rolling of one dice or tossing of one coin. You are talking about 3 things happening together. That is what is compound event. Now, when you talk about compound events, there are 2 possibilities. One is called dependent event, one is called independent event. Can somebody give me an example of a dependent event versus independent event? Let's look at the practical part of it. Let's see if you are able to relate to certain concepts. Give me one example of a dependent event and one example of independent event, and then we'll figure out how do we deal with the probability of that. So compound event meaning there are multiple events happening, okay? Be it rolling of 2 dice, rolling of 2 coins, picking up something multiple times from a bag, whatever it be. So I want you guys to give me an example of a compound event where the events are dependent and compound event where events are independent. Yes, Arav?
For like a compound event, so you can like go to like a store and like buy like a random box, saying like it can use 1 marker, 1 notebook, 1 like pencil, and then like it randomizes what you get and you get it.
Okay, anybody else? So basically I'm looking for example of compound events. One scenario when they are dependent and second scenario when the events are independent of each other. Yes, Sarvita.
So like a compound event with dependent events would be like if you take 1 card out of a bag and then you draw another card without replacing the first. And then a compound event with independent events would be like if you draw a card out of the bag but then you put it back and then draw another card from the same bag.
Did everybody hear what Sarvita said? And does it make sense? Okay. So that was a good example. Okay. Again, same way, I can also, I had one idea in mind. Okay, if I'm talking about compound event and both are compound events, dependent and independent events. I was thinking that, okay, this is dependent event and this is independent event. So be it rolling of dice, rolling of die, tossing of coins, multiple coins. These are examples of independent events. You are rolling one die one time, 2 times, 4 times. Your one output has no influence on the next output. Yeah? Or the subsequent outputs. If you are rolling a die one time, you got 4. Next time, nobody tells you that, okay, nobody can guarantee you that, okay, next time it will not be a 4, it will be something else. Or the best gambler even cannot tell you that, okay, next time when you roll it, first time you got 4, after 4 attempts, 5th time you will get another 4. Nobody can guess that. Arab, stop crying. Okay, so these are independent events. Even if you are doing it multiple times, there is no guarantee. Okay. Now, when you look at dependent events, the thing that I had in my mind was, okay, I have a bag. I have, let's say, 3 black marbles and 4 blue marbles. In the first pick, when I am randomly picking one marble, being blindfolded, my probability of getting a blue is 4 out of 7. I got 4 out of 7. First I got as blue. Next one, also being blue, if I'm trying to find out the probability of getting first blue and second blue again, so I have picked one blue already, so I'm now left with only 3 blues. So next probability of the next event being blue, next marble being blue is again now 3 out of 6. Because if my first one is blue with this probability, my second one being blue will be 3 out of 6. Here, the second event's probability being 3 over 6 is dependent on what is the first one's pick. Okay? So that's what is dependent event. That's why I was saying that, okay, when one outcome influences the second outcome, they are called dependent event. But Sangeeta made my job much easier by saying that, okay, you have a pack of cards. Let's say you have 52 cards. And you pick first card, picking the card and then keeping it aside and then picking the second card. They are dependent events because now next time when you are going for the pick, you have 51 cards and accordingly you will pick. But if you have the same pack of cards, you pick something and put it back and then make second pick. Keep going on. That was a much easier description or interpretation of what is a dependent event versus what is not. If you are putting your things back, you are starting from ground zero. No change to a possibility or probability. Here when you are looking at this, you have picked up something, kept it aside, then you are making second pick. So you are, based on what your pick is, first pick is, your total number of options also have reduced, your probability of getting something also would have changed. So this was a very good example, easier example. So thank you Sangeeta for making my job easier. If I give picking a marble from the bag as an example for dependent event and rolling a die as an independent event, and these are two different things and people might get confused. But Sangeeta said, okay, you have a pack of cards, when you are putting the card back, you are talking about independent event because your probability remains the same. When you are keeping it aside and then you are going for the second pick, that is when it's a dependent event. Yeah? Is everybody clear about it now? Now let's look at how does it translate into math? How does this whole calculation work? Okay. So now let's go back to the situation of dependent event. Okay. Let's say we have, let's go back to the situation of independent event first. So you have, let's say, 2 coins, coin 1 and coin 2. both are fair coins. You are tossing them and trying to find out different probability, okay, of a compound event. So two events, two coins being tossed. What is the possible? Okay, and let's say 3 coins. 2 coins is too easy to deal with. You are tossing the coin and trying to find out the probability of all coins, probability of getting 2 heads or 2 tails. We are tossing 3 fair coins and we are trying to find out the probability of the total probability of getting 2 heads or 2 tails. Same problem, little different flavor. I'm saying that you have 3 coins, which are 3 fair coins that you are flipping. What is the probability of getting 2 heads or 2 tails? How will you find that out? So let me solve that, and then because idea was to build a concept out of it. So first thing first, when you are talking about 3 different coins, three fair coins, what is the total number of events? Total number of events when they are independent events. First one gives you 2 possibilities, second one gives you 2 possibilities, third one gives you 2 possibilities. You multiply them. That is the total number of events. 2 times 2 times 2. Okay, beta. Alright, yeah, you can carry on. But so total number of possibilities, you multiply the number of events. Why? Because if you look at it, we said okay, head, tail, head. This is with the head. Both head. Head with a tail, have tail, head. And then with head, you have the same thing. Head, tail, tail with head, tail. So basically what you're seeing is, if you have only 2 coins, every coin, it had 2 options, that blew up to 4 options. If you had 3 flips to be done, this had 2 options, this had 2 options, this had 2 options. It's getting multiplied and becoming 6 options. So that became your way to find the total number of events. So when you have to find out the probability of anything, you have to find out the total number of the concerned event divided by total number of events. So total number of events, you can straight away find out that you can get 2 into 2 into 2. So total number of events will be 8. That is the first thing. Now you are trying to find out probability of getting 2 heads or 2 tails. Now look at this. 2 heads or 2 tails. We are talking about this combination. These two is giving you 2 heads. And this combination gives you 2 tails. So this is 2 plus 1, 3. And then again here also you will see that okay, you are looking at 2 tails here, and that's it. So 2 heads, this one and this one, 2 heads are coming, these 2 here. Now if you go in this path, you are not getting that, so this path is giving you 2 heads. And then when looking at 2 tails, you are looking at this as one option, and then this as another option. So you are talking about 1 plus 1 2 plus 1 3 plus 1 4 and then plus 1 5. It is 5/8. Okay, but now go back to the situation here. Okay, we have to find out the total probability of 2 heads or 2 tails. If you look at the combination here, you have 2 heads or 2 tails. First thing is, all heads, see if you take out the 2 heads and 2 tail options, what you're left with is all head options or all tail options. This is not head, this is tail. That's why I was wondering. Tail, head, and then this tail option. Yeah. Okay. So basically, what I was saying was that if you have to look at all the combinations where you're getting, it's too messy to interpret anything. That's not the way to look at it. Okay, so what I was trying to say first is there are two things. Okay, let's summarize this in a simpler way. If you're talking about finding out the probability of a independent events, any scenario, okay, there are 2 things that you have to find out. One is total number of events, and you have to find out the number of the concerned event. Total number of events, when you're talking about the independent events, when one event doesn't have any influence on the second or the third, then every event has certain number of possibilities. First coin has 2 possibilities, second coin has 2 possibilities, third coin has 2 possibilities. Total number of events will be a multiplication of all the 3. That is how the total number of events is always going to be 8 here in this scenario. If you are talking about, let's say, rolling 2 dice, rolling die 1 and die 2, 1 and this is 2. Here number of possibilities are 6 and here you have number of possibilities 6. And rolling first die versus second die doesn't have any influence on each other. So total number of events will be always 6 into 6. So this is one takeaway, okay? If you talk about independent events, your total number of events would be multiplication of the 2. Your denominator will be multiplication of these 2. And then when you have to figure out what your numerator would be, the event type that is in contention that you are trying to find out the probability for, you will have to derive that by interpreting the breakdown, like what I was trying to show here. And I know it got a little messy, so it was difficult to interpret. So let me clean it up and then we'll come back to this. Okay, so let me change the question a little bit so that you can relate it better. I am throwing 2 dice, die 1 and die 2. Okay. What is the probability of getting a sum more than 8? What is the probability of getting more than a sum of greater than 8? I'm throwing 2 die. So die, as you guys know, it is 1 to 6. To 6. This one also has 1 to 6. My question is, when I'm rolling 2 dice, what is the probability of getting a sum of more than 8? So what I'm trying to relate here is this die, rolling of this die or this die are independent, and we are trying to find out a compound event, meaning a sum of outcome of this and this to be more than 8. Did everybody hear the question, or okay? Adya is always the first one to respond. Is everybody with me? Everybody heard the question? Okay. So let's see who all can solve this one And I promise we'll have more interesting problems to solve tomorrow. I'll get few interesting ones to look at tomorrow. So the question is, we have two dice, fair, let's say fair dice, okay? There's no manipulation that you can do. We are rolling two dice, and the question is, what is the probability of getting a sum of the two numbers more than 8? And guys, one more thing. I know we are learning a lot of things in the class and it's easy to forget. I would start recommending you guys to make sure that everybody watches the video of the class at least by scrolling through a little faster. Wherever I'm doing some preaching, you can skip that part. But whatever we are learning in the class, just make sure that you guys are watching it, okay? Every 1 hour video, 1 hour class, I don't think you have to watch the video for the entire 1 hour. You can crunch it by 15 to 20 minutes, okay? But make sure that every class's video you're watching to revise it, okay? Because I keep on prescribing you guys not to take notes, and that is the purpose. Yep.
1 by 3.
1 by 3. Up getting anything more than, okay. Yep, Sanvita.
I got 5 over 18.
5 over 18?
Yeah.
Okay. Okay, we have just 3 more minutes. I want to just solve it for everybody to follow it. And again, as I said, make sure that you guys start watching the video of the class. Don't watch the entire 1 hour. I waste a lot of time. Yeah.
Actually, can I change it to 1 by 4?
1 by 4. Okay. Now you cannot change anything. When I do it, you will see if you did whatever you did was correct or if you missed something. So we are talking about die 1 and die 2, both being rolled, and they are independent. So if I have to find out the probability, I have to find out number of events that is in question by total number of events or total number of possible events. So first of all, there are 6 events here, 6 events here. For every one of them, there are total 6 possible numbers. For every one, I can get 1, 2, 3, 4, 5, 6. So total number of events would be number of events 6 here, number of events 6 here. Total number of events becomes 6 times 6. Every one of them, there is 6 possible events. So we are talking about total 6 into 6, 36 events. Now it says, what is the probability of the sum being more than 8? See, I cannot have 1 and 6, minimum of this and maximum of this is not giving me 8. So it has to be greater than 8. So the only option I can think of is 3 in the first one and 6 in the second one. This is one option. 4 in the first one, then 5 in the second one, and then 6 in the second one. Or I can have 5 in the first one, then 4 in the second one, 5 in the first one, 5 in the second one, 5 in the first one, 6 in the second one. Okay? Then look, so with 3 I can have only 6, with 4 I can have 5 and 6, that gives me a number more than this. And with 5 I get 4, 5 and 6, 3 options, which gives me more than 8. And with 6 I get 3, 4, 5 and 6. So 3 in the first one, only option that gives me more than 8 is 6, with 6. 4 in the first one gives me these 2 options. Okay? More than 8. Hello. Now your class starts. Come over. With 4, I get 5 and 6. Sit with that. Sit with brother. It's okay. You're younger brother, right? Sit down. With 4 I get 5 and 6 as 2 options. With 5 I get 4, 5 and 6 as 3 options, which gives me more than 8. With 6 I get this many options. So total number of options we are talking about 3 plus 3 6 plus 3 9 plus 1 10. So 10 over 36. 10 over 36. This translates into 5 over 18. Yep. Everybody got the same answer? At least, did I explain that okay, or I got you guys more confused? Okay. So basically, now in the next class the class tomorrow, we will deal with little more complicated problems. This is where we will try bifurcating between dependent events and independent events and some interesting ways to solve them in a much more efficient way. Okay. So far we were looking at breaking it down to different options and then solving it. Now we will find out some more interesting conceptual ways to solve dependent and independent events in case of compound probability scenarios. Alright? So with that being said, I'll let you guys go and come back to bother you tomorrow. Again, Arav is trying. Bye bye, bye bye, bye bye.